All right, welcome to COMP110, everybody. I'm Chris Jordan, and this is UNC's Introduction to Programming and Data Science. This is Computer Science 110, and I'm so excited to have you on the stream remotely. This is a strange semester, but we've got a lot in store that we've been working on over the summer, and I'm excited to have you along for the ride. So before we get into some of the details about the course, I think it helps to know what it is that this course is focused on at a high level. And then I want to introduce some of the people who you'll be working with over the course of this semester. So the course objectives for COMP110 are primarily about introducing the art and practice of programming. We're going to be focused on the fundamentals of programming, and our application focus is going to be in data science. So programming can be widely applied to many different problem areas, but we'll be spending a lot of time looking at how we can apply programming to processing data. The concepts that we're going to learn in this course are fundamental to all programming languages in modes that you'll be working in. So what you're going to leave knowing coming out of COMP110 is what it feels like to be a programmer. And I hope that you enjoy it. I think that many of you will find that you enjoy it way more than you're probably expecting right now. We'll also look at how we're going to process data, and one of the most fundamental tangible skills that I think you'll exit with is the ability to write programs that read some data into them, analyze them, and produce reports or visualizations. We're going to be gaining some practice thinking computationally, and this really means just trying to break down problems and specify them very concretely and in as simple of terms as we can. We're going to be thinking algorithmically and practicing thinking how can we provide a fixed size set of instructions that can process an arbitrary sized problem. We'll be looking at that as we get through the semester. In computer science, you're going to hear me say this a lot through the course of this semester, is all about abstraction. How do we take some process that's complex and seems a little bit overwhelming and abstract it away such that we can think of it in much simpler terms. And we'll talk about abstraction later in today's lecture. You're going to understand what the fields of computer science and data science are fundamentally about, and we'll introduce some of the concepts that you might be able to dig into deeper if you decide to continue in these fields. And if you don't continue in these fields, you'll have the vocabulary and the experience to be able to work with people who do. What I want to say is you all should have received some instructions on how to get registered for Poll Everywhere through Sakai. So we're going to be using Poll Everywhere this semester to interact with one another and to get responses and ask questions. And so one of the ways that I'll be able to take questions, and we'll come back to this once we get there, is through Poll Everywhere. There's currently a poll up right now, and it's asking just a few background questions. I'll come back to the results of that poll here shortly. This is a URL we'll be using throughout the semester, and I'm not posting the full URL here because this is just for UNC students, and since we're streaming live on YouTube, I want to keep Poll Everywhere's responses to registered UNC students only. But go ahead and bookmark that. You'll be coming back to it frequently this semester, and this is where we'll collect feedback from everybody. So just to quickly introduce who it is that you'll be working with this semester, I'm Chris. I'm from North Carolina originally. I was born in the Charlotte Concord area and spent from K through 8th, 9th grade in this area. I moved to Rutherfordton, North Carolina in high school. And when I was in Rutherfordton, I realized that I really wanted to learn how to program and learn a little bit more about computer science, but I was challenged by there not being access to resources at my high school that were computer science courses. So I went to UNC thereafter. I graduated from UNC in 2007 with a degree in computer science. So I've been through the same program, and it's really fun to be back at my alma mater working with you all. I lived in the Everett Residence Hall on Old Campus Lower Quad, and yeah, loved my experience at UNC. I went to Brown University for graduate school thereafter, and again studied computer science. Spent a number of years in industry doing software consultancy, and then joined UNC to teach back in 2015. So this is now the 6th year that we'll be doing COMP110, and I'm happy to say that I think this is actually the best rendition that we'll have for you yet. We put a lot of time this summer into figuring out how to reinvent the course for the world that we're living in today. And I think we've got some really cool things up our sleeves that we're excited to share with you as we move through the semester. But this course really is driven by and supported by a cast of people that is way larger than myself. And I want to give a chance for you to meet some of these folks. And I'll have a list of the undergraduate teaching assistant team here in just a moment. So undergraduate teaching assistants are who primarily run, in many ways, the COMP110, the course at UNC. And this course would be impossible without them, right? I couldn't do this alone. And so there's a team of over 45 undergraduate teaching assistants who you'll be working with closely through this semester. And we've got a number of them that I'm going to introduce to you here in just a moment, right? I am going to argue, and now after 5 years, I think I've proven that we have the strongest team at UNC. I stand by that, and you're really going to love working with them, right? So they'll be able to help you with things that you're working on through the semester, one-on-one office hours, but they've also helped me come up with lecture ideas. The intro video that you saw, that was made by an undergraduate TA, and they've helped me build problem sets. They're great. Each of you will be assigned 2 undergraduate teaching assistants who are primarily your lead point contacts in this course. And there will be office hours where you'll get to meet and work with these TAs that'll be open over 40 hours a semester, all right? Over 40 hours a week throughout the entire semester. So let me jump in and introduce some of these folks. So I'm actually going to jump straight to Annika. And Annika, if you will introduce yourself.
I go by she, hers. I took COMP110 last fall, and I think computers are super fun. So I'm glad all of you are taking this course, and I'm excited to work with you.
Great, thank you. Fernando.
Hello everyone, my name is Fernando. My pronouns are he, him, his. I took COMP110 last spring, and I'm excited for this semester because I think we have some really exciting things planned.
Harmon.
Hey everyone, I'm Harmon Martin. My pronouns are he, his. I took COMP110 in the fall of 2019, so my first year at Carolina. I spent this past summer as a software engineer intern for the Department of Defense. I can't wait to work with all of you.
Great. Izzy.
Hi everyone, I'm Izzy Ford. My pronouns are she, her. I took COMP110 way back in spring of 2018. I absolutely love TAing for COMP110. And this past summer, I was a software engineer at Microsoft intern. Which is a really great experience. I didn't think would have been possible when I was in 110, but this class will open up a lot of pathways and opportunities for you. So best of luck.
Thanks, Izzy. Janet.
Hey, my name's Janet, and my pronouns are she, her, hers. I recently took COMP110 over the summer in the second summer session, and I'm really excited to share with you guys all the new alleys I opened up with COMP110 and all the different ways you can like tinker with like code and stuff.
Thank you. Kyle.
Hi, I'm Kyle. My pronouns are he, him, his, and I took COMP110 this summer. I'm really excited to start working with you all because I really love teaching, and I hope to apply those skills to my new favorite subject, which is computer science.
And Madison Barber.
Hey everyone, I'm Madison. I use she, her, hers. I'm majoring in astrophysics and comp sci. I took COMP110 in the spring of 2019. And this summer, I was able to combine my 2 majors and intern at NASA Goddard Space Flight Center, coding models of transiting planets. So I'm really excited to help everyone learn comp sci this semester.
Awesome, thank you. Mackenzie.
Hey y'all, I'm Mackenzie. Similar to Izzy, I took 110 way back in the spring of 2018. This summer, I was a software engineering intern for B of A, and I'm super excited to work with you guys. Chris and COMP110 was what made me switch my major from French to comp, and I hope to indoctrinate some more of you along the way.
Thank you. Ella.
Hi, my name is Ella. My pronouns are she and her. I took COMP110 fall of 2019, and I hope that you guys fall in love with coding and switch your majors kind of like I did.
All right, Sharik.
Hey everyone, I'm Sharik. My pronouns are he, him, his. I've also took COMP110 just this summer. Programming can be hard and frustrating at times, but we've got a fantastic team here at COMP110. I think you guys are really going to have a blast.
Last but not least, Yang.
Hi everyone, I'm Yang. I'm currently a junior here at NC Chapel Hill. He, him, his. I took Comp 110 in fall of 2018, and I'm really excited to work with you guys this semester because I really like working with people so that we can find creative solutions to a lot of the problems that we face today.
Thank you, Yang. So these are just a few of the wonderful undergraduate TAs that you're going to meet along the course of taking 110. Many of the others have courses that conflict with this, but that's okay because they're available at many other times in the week. A full list of the TAs that you're working with, and I think we are actually picking up one more, is on this slide. So you get a sense that with 45 people here to support you, we can actually do some things that smaller classes can't. Like I said, with 40 hours of office hours open throughout the week, we tend to have a wait time that I'm proud to say we beat Uber. You can get help in office hours faster than you can get an Uber on campus. And so having highly reliable access to quality instructional support that's when now that we're remote, it's only a Zoom call away, is one of the real secrets to making this course something that I think a lot of undergraduates at UNC find highly rewarding. So I next want to introduce a very special member of the team, Kaki Ryan. Kaki, can you jump on Zoom real quick and introduce yourself?
Yes. Hello, my name's Kaki. I use she, her, hers pronouns. I actually took Comp 110 fall 2016 as a freshman, and now I'm in graduate school studying computer science when my major coming in as an undergrad was not computer science. So hopefully we can convert some of you and make this the best semester yet.
All right, thank you, Kaki. So Kaki will be one of your primary contacts who's helping me run this course. She's been working with me, as you heard, for the past 3 years, and I'm so glad to have her back this fall. I thought that she was leaving us for good when she graduated, but the BSMS program is an exciting opportunity in computer science. So the next thing I want to do is actually introduce two people who are members of the extended Comp 110 family. And I'm very excited to have them join us today. And I'm hoping to have some of the folks who started in 110 and are now out in industry pop in our calls from in our classes throughout the semester to get a sense of where people go with computer science. So I will start with Rasika. And Rasika, if you could jump on the Zoom call real quick.
For sure. Can you see me?
Go ahead and introduce yourself.
Okay. Hi, my name is Rasika. I'm from Chapel Hill. I came into UNC as a transfer student my sophomore year, completely undecided in major. I was like a miscellaneous nerd. I didn't quite know like what that translated to in terms of what I wanted to study. So I took Comp 110 my second semester sophomore year, which was my introduction to programming. And I was immediately very drawn to it because it struck me as a really powerful means to innovate in whatever field you happen to be passionate about. So I picked it up as a minor. I graduated last year in 2019, majoring in economics, minor in CS. Since then, for the past year, I can't believe it's been a year, I've been working at a nonprofit research institute called RTI International, which is centered in RTP. Within RTI, which is a huge company, my particular center researches tobacco and cannabis usage to inform policy decisions. We work pretty closely with the New York and Florida state governments. So if you hear like, I don't know, a speech by government officials in either of those governments talking about like what percentage of youths are doing X, Y, and Z with tobacco, there's like a good chance that me or one of my colleagues actually came up with that statistic, which is pretty cool. My job title is economist, but I actually mostly do software development. Right now, the project that I'm on is implementing this massive graph database system to track all the data that comes into our center throughout all of the studies that we do. And most of our studies are online surveys that are advertised on social media platforms. So there is a fair amount of fraudulent data that comes in. And the idea behind this new system is that by having all of the data in one place, we'll be able to use AI to improve our fraud detection processes, which is pretty cool. Yeah, it's a lot of fun. I spend all day in JavaScript designing and implementing it. And when I think about how I got this job, that path really started with 110, which is where you guys are right now. So I'm looking forward to your introduction to computer science.
Great. Thank you, Rasika, for joining us. And it's been awesome to watch your progression there. And I'm excited to see where you take this new position. I'm going to switch over to Izzy Hinks, who is another recent graduate. And Izzy, if you could tell us just a little bit about your experience, some of the research you did, and what you're up to in graduate school.
Absolutely. Yeah, hi everyone. My name's Izzy Hinks. I'm from Apex, North Carolina, and I took COMP110 with Kaki actually in the fall of 2016, my freshman year. And we graduated this past May. And I did actually come in expecting to major in computer science, but I also have a huge passion for environmental science and environmental issues. And I was really interested in being able to combine the two. So although I was one of the few that came in CS, I ended up doubling in CS and environmental science to include both of my passions. And I was really grateful to be able to do that. And COMP110 was absolutely influential and elemental to my decision to pursue computer science. So I think the class is what you make it, and definitely utilize these wonderful resources who are your TAs. They're extremely knowledgeable, and hopefully you agree with me in thinking that they're wonderfully approachable and supportive as well. So that's my biggest piece of advice to you is utilize those resources, and don't be afraid to ask questions, because no question is a stupid question, and they're there to help you. So currently I'm a PhD student at NC State studying geospatial analytics. And specifically, my project is using satellite imagery, remote sensing, and algorithms to help smallholder farmers in the eastern Indo-Gangetic Plains, which are like northeastern India, Nepal, and Bangladesh, because this region is disproportionately affected by climate change and also has significantly greater amounts of poverty than other places in the Gangetic Plains. So we're using adaptive strategies to help these farmers improve their crop yields without the introduction of expensive technology or pesticides that they aren't able to realistically use. So I'm really, really excited to be able to apply what I learned both as a TA for COMP110 and throughout the majors that I pursued in the real world. So yeah, I think you're at the start of a really great journey, and I'm excited to see what everyone gets from it.
Wonderful. Thank you so much, Izzy, for joining us, and the rest of the TA staff and Rasika. I'm going to go ahead and close out the Zoom because I accidentally was fumbling around with something earlier. So, but it was great to see everybody, and you all will get to work with these folks and hear some more from our alums here in the near future. So thank you all, and I'm going to bring it back to a little bit about who is it that's in the class with you all right now. So you may have seen that I was trying to pull up the poll, and I forgot that I actually couldn't do this while we were streaming on Zoom, so I apologize for that. But one of the things that I think is important to understand is who is it that's actually in COMP110 with you. And that's hard to get a sense of when we're all taking this remotely. So in the initial in the initial poll everywhere questions, I wanted to share with you some of the results of where students are coming from in order to take COMP110. So the first question was, where's home? And what I want to say is the leading, actually I'll start with the least percentage and work our way up. So 9% of you are international students. And that's awesome. I love working with international students who bring a diverse perspective to the course. And many of you are international right now due to travel restrictions and whatnot. This is a Carolina away course. And you'll hear me talk a little bit more about some of the things that we'll be doing to help make that a better experience for you in just a moment. Out of state is coming in at 11%. And that seems to be about right based on, I think the university mandates about 18% of students are out of state and the rest are in state. And then if we go to in-state, we've got some interesting numbers here. So the 910 area code is going to be the least represented here, but the 910 brings such a vibrant part of the state into our class. We've got the next is my home and native, the 828 folks. So the Western North Carolina folks are 16% of the class. And I still have my 828 phone number. Love seeing and meeting people who are from Western North Carolina. If you're joining us from that part of the state, welcome. And I understand that my mom might actually be joining us from that part of the state. So hi, Mom. This is the first time she's watched me live. I'm very nervous, but love you, Mom. Thanks for joining the stream. And let's see. So we've got next. It's actually, this isn't what I would have expected. And this seems a little bit strange. 704 is the next biggest population group with 21%. This is the Charlotte area. And then last but not least, we've got the 919, and that is 34% of the class. All right, so we're coming from all over, and we represent a very broad range of geography with the state well covered, and then we've got folks joining us from China and around the world. So love seeing that, and let's talk a little bit about the next question, which is what is your primary major? And I think this is one that comes as a surprise to most people. So in this class, COMP110, there are a number of people who are computer science majors, but it turns out that's the minority in the class. Based on the results so far, comp majors make up only 37% of the class. Right? So the majority of the class, the other 63%, are not comp majors. So if you're in COMP110 and you're thinking like, I'm looking at English or psychology or environmental sciences, am I going to be out of my league? Is this like an intro class only for comp majors? And absolutely not. This is a class that is primarily taken to satisfy breadth requirements in many other disciplines. And so again, the majority of the class, 63%, is not comp. Right? And the last question is also one that I think comes with a little bit of anxiety for those of you who are in the course. And there's this assumption that like you have to have prior programming experience to succeed in COMP110. And I'm glad to say that most of you do not. 55% for prior experience. And let me just box that real quick. 55% have no prior experience or less than 1 month. And this course is really designed to support you, and we expect no prior programming experience. The next biggest group is 2 to 6 months. So maybe you've taken a course like APCS Principles or something, and that's another 24%. So most of the class is in this category of very little prior programming experience. Right? And so if you have no experience, you're in the right place and you're going to be just fine as long as you put in the work to succeed. All right. What I want to say is in the upcoming weeks, you will be in smaller group Zooms. This class has 593 students enrolled in it, the last I checked. And that's the largest section of a single course ever held at UNC. It's so large that we can't fit into a single Zoom. Zoom caps out at 500 people. And so what we're going to be doing is breaking you all up into smaller groups and assigning Zooms, and we'll worry about those logistics later. And then we'll have a combination of Zooms and streams moving forward in the semester. But you will get a chance to work in small groups and interact with your peers and get to meet one another. As you heard me say, no prior programming experience is needed, but some is okay. So those of you who have some prior experience, you're going to see that the ideas translate, but we are starting from ground zero. We're starting from scratch, and we assume nothing coming in. This is a rigorous introduction to programming, so it is a STEM class at UNC. We're going to hold you to a very high standard, and you'll put in some work. But I think what's really fascinating and captivating about programming is how rewarding it is for the effort that you put in. You see results come out on the other side. So some of you probably have questions about the instructional format of COMP110. This is a strange semester where some classes are synchronous, some are asynchronous. And here we've got a synchronous live stream happening. Well, there will be parts of COMP110 that are synchronous, like this stream, and there will be synchronous components moving forward. We're going to try and use synchronous time to be as effective as possible. And by that, I mean, if we're coming together, I want it to be interactive. In future synchronous sessions, we'll be doing more polling. We'll be doing small group work activities. It'll be to come together and practice, as opposed to like me lecturing at you and you learning. Right? So there will be some asynchronous components of the course as well, where some days, and you'll have advanced notice, we will assign videos out and have you learn some of the primary lessons that we're trying to teach in shorter videos that you can go back and rewatch and take your time to move through. And what this is really affording is the ability to make maximal use out of this new flexibility that we have. Teaching remotely is a strange, new, challenging thing for everybody on campus and around the world, I think. And what we kind of reflected on over the summer as we were thinking about how do we improve this course, we shouldn't try and shoehorn ourselves into one modality or the other. We should try and use both in order to get the maximal benefits from each. And so we're going to be mixing it up, and we'll be able to adequately prepare you for what to expect in the weeks ahead. You should note that programming, and you'll hear me say this multiple times, is a practice skill. And when we get into working on exercises and having projects, typical of most STEM courses at UNC, there's sort of a 3x multiplier on the number of hours that you are expected for credit. So if a 3-hour class often has 7 to 9 hours of expected work in a given week. So do keep that in mind. This is a rigorous course. If you're in a semester that's chock full of STEM courses, might maybe meet up with an academic advisor. But if this feels like a reasonable workload, I promise you, if you put the time in, you will do just fine and come out on the other side in a very good place. So what if it's 5 a.m. for you right now? And for those of you who are joining from China or India, I think it is about 5:13 a.m. in the morning. And hopefully you can also be watching this after the fact, but we're going to be sending a survey out. And for folks who are joining us from the international locations, we're going to have an alternative way for you to be able to participate in the class in your time zone, right? It's really an unfortunate side effect of being fully distributed and around the world, that the time zone of this particular class, 5 a.m., no one should need to be awake at that hour. And so we're going to try and figure out a way to work with you on this and be sure that there's a maintainable schedule moving forward. Look for that survey in the next week. So what will you actually do in COMP110? Like, what are the things that we expect of you as a student? These are going to be broken down into 4 different sort of task areas. So first, there's going to be some preparation. There will be videos assigned starting later this week, towards the end of the week, to prepare and start learning some fundamental lessons and concepts on your own time and working through some tutorials and lessons. And we expect you and ask you to take notes on these things and apply whatever learning strategies work best for you for learning new material and taking on new concepts. We will have some warm-up quizzes, and on those we expect that people are able to use the notes that they take. And it's going to be honor system, right? Because we are remote, but I have full faith in you as Carolina students to be honorable here. When we take the warm-up quizzes on the prior day's videos or readings, those you can use notes on. So how is participation measured? Well, in our synchronous gatherings, there's Poll Everywhere, which you all have already been responding to. We have over 550 responses to the current poll. So you're already on top of it there. Thank you for being fully prepared for today. We're going to be practicing things that are called environment diagrams and writing code, and some of this you will hand in through Gradescope. Don't worry about that. We don't have anything on that side right now for you to worry about. And there will be some ungraded challenge problems in lecture that are Poll Everywhere style problems, where we put out a question, and once we're in Zooms, you'll be working together on those questions, discussing them, trying to solve them on your own. And those are really for practice and to try and focus in on some of the concepts that are most difficult for students to learn. There will be practice that you do on your own outside of class that will be, we'll have some diagrams that we ask you to make. We'll give you some computer programming, a listing of code, and we'll ask you to diagram what that would look like in memory. We'll teach you everything you need to know step by step in order to do this. But it's just like working a problem in any other math or physics class. And there will be some programming exercises that are smaller problems that are not going to take too much time, but focus on a specific concept and don't require a whole lot of creativity, but besides just solving the problem. There will also be a mastery component of the course. And this is, I think, the most exciting one, because projects were something that we're doing for the first time in a very different way this semester than we had in the past in COMP110. We tried this in a pilot over the summer, and with projects, we give you a very open-ended prompt and some requirements that are clearly laid out in a rubric, and you get to apply your creative energies to building wild and amazing things. This summer, we were totally blown away by some of the lessons or by some of the work that we saw come in. And so I'm really excited to see what you all do with more time. In a summer class, it's pretty short, right? But we've got 15 weeks here to work, and these will be spread out through the semester, about one every 3 weeks. And I'm really excited to see the creativity here. There will be some quizzes. These will be timed. They'll be done on Gradescope. We'll get to talking about those in the format. It's not worth worrying about now. In the final exam, those dates are being scheduled by the registrar currently. As soon as that gets locked down, we'll deliver a schedule of dates that's a little bit more precise, and you can look for that in the future. So just to get through some of the other administrativia, the grading breakdown. So the preparation and practice is 20% of your grade, and mastery is the other 80%, right? So participation, showing up to Poll Everywhere, contributing in small group activities is 4%. And the exercises that you're doing and working on and handing in, that's another 16%. Projects make up a third or almost a third of your final grade. And this is really a chance for you to go wild with trying to create something that you're proud of and that you'd be excited to share with other people. And I think you'll have a lot of fun with the projects. And for really strange policy reasons, the final exam starts out worth the rest of your grade, but there are some weird constraints here, and this is just to satisfy some really strange UNC policies. But basically, there are 4 quizzes, as I mentioned, and each of those is worth 8% of your grade. And as you take each of those quizzes, your final exam grade is worth less and less and less. Taking 3 of those 4 quizzes is required in order to pass the class, so you do have to take those quizzes. You can't just roll the dice and put it all in the final. And you can be absent for up to 1 quiz. If you miss a quiz, it's no problem. Your final exam will just be worth 24% rather than 16%. All right. This is all laid out in the syllabus as well, which you can find on the course site, and that was posted in Sakai, and I'll have a link to it in just a moment. All right. So some more serious stuff before we get into some introductory computer science concepts. We do take collaboration and honor code violations seriously in COMP110. This is true of all Carolina courses. And so I just want to lay out sort of the rules that you should expect to adhere to in the course of the semester. For general course content, that means the things that we talk about in lecture, documentation that's on the website, examples, code from demonstrations we do, study guides that we're producing for you to help study for exams and quizzes. Collaborating on this with your peers or tutors or whoever is totally fine. We encourage it. I think this is the right thing to be focused on when it comes to working with others, just trying to discuss ideas or flesh out things that are outside the scope of what's required of the course. But for graded assignments, we have some higher expectations that you're going to be working individually. And the reason for this is because programming is a skill that you just have to develop internally and on your own in order to be good at it. And so the best way we've found in COMP110 to encourage this growth is for the graded assignments to be done by you individually. So we don't permit collaboration on graded assignments. These are the exercises, the projects, with anyone other than undergraduate teaching assistants. And we are happy to support you internally from our side as a team, working on these things and answering your questions and trying to help be sure that when we give you help, we're increasing your level of understanding, not just giving you the solution that you're looking for, right? So what are the things that we would consider collaboration? Looking at or sharing your screen over Zoom, letting someone else look at your screen, talking about your code in a level that's like very step by step, copying or sharing code from Stack Overflow or Chegg or GitHub or Course Hero, or asking for help from peers on GroupMe for things that really shouldn't be discussed with anyone other than the undergraduate teaching assistant team. As I mentioned, we've got tons of availability and you will be able to get the help you need from our team. And in doing so, we will help you better understand the material so that ultimately you succeed in the course. All right, so that's a very long-winded pass through some of our policies, which are also in the syllabus in a more detailed way. What I want to say is I'm going to open up a poll on Poll Everywhere right now. So let me just change that over real quickly. And this poll will allow you to ask questions. All right, so I'm going to activate this now. And behind the scenes, Kaki, your TA who you met, will be moderating these questions. And we will try to move through these questions in as best we can. And if there are questions that seem a little bit too specific to content that is expecting some level of understanding beyond what we've discussed so far in the course, then we might redirect you to office hours and ask you to ask those questions there. But if your questions generally seem to apply to everyone in the class, then we would be happy to answer them on Poll Everywhere. So I'm going to open this up and I'm going to go through a few more slides while I'm waiting for questions to come in. But we will have these checkpoints throughout our live lectures so that you have an opportunity to ask questions and we can get some feedback from you. So if we don't get to your question, because there might be more than we can get to in our allotted time, do come see us in office hours and I'll tell you that schedule here shortly. So I've already seen a question come in. Is there a required textbook for the course? The good news is no, you will not need a required textbook. You will not need to purchase anything for this course. And these lectures will be uploaded after class to the course site. So you can be assured of that. So programming is a practiced skill. And you're going to hear me say this over and over again, right? And what do I mean by that? Well, just like playing an instrument, just like painting or writing cursive letters or dancing, any of these things that are listed on this slide, any other practice skills require time and effort spent on the task of just immersing yourself in the problem that you're trying to grow as someone who can practice that or given skill day after day. And so the time that you spend individually practicing programming is going to be your #1 key to success in this course. This isn't a course that you can just memorize a bunch of facts and regurgitate them at the end. This is a class where you really need to master some important skills. All right. This is a very different course from knowledge-based ones, as I mentioned, where you're just trying to understand a very large body of work or a big historical period of time. The number of concepts that you're going to learn in this course is probably much smaller than many other courses, but they all kind of interplay with one another in some really fascinating ways, and you'll get a chance to experience that soon. All right. Everything we do in this course is really geared towards trying to help you become a programmer and for you to grow and succeed as an individual. And so this is where some of the collaboration policies come from. This is where the way that we structure our office hours and design those interactions is really trying to help you grow as a programmer to do very well. All right. So before I talk about this slide, let me just take on a few more questions here that have come in from chat. So if you take all 4 quizzes, yes, you can drop the lowest quiz effectively. If your final exceeds your lowest quiz score, we'll just treat you retroactively as if you were absent for that quiz. So there's no penalty. And in fact, there's a benefit to trying to take all 4, but there's no penalty if you only take 3. For the smaller group meetings, we're going to be, those will be led on Zoom by your teaching assistants. And so we'll have that organized. The plan is for next week. We'll be looking for some information from you in that survey I mentioned in order for us to help navigate forming these Zooms, but the UTAs will lead those. And I'll be live for that those meetings as well. So it'll just be distributed Zooms with a stream that's sort of coordinating centrally. I will talk about office hours and that sign up process in just a moment, and we'll talk about what you need to do to get started here shortly. I'm going to close questions just for a little bit and reopen them as we get into another section here. But these are great questions, and I appreciate you all contributing to asking them. And I should have had those things in the slides. So let's talk a little bit about how you spend your time. And I want to try and cast this in the light of a skill that I've never actually acquired, which is learning how to paint on your own. It's something I'm envious of for folks who can. If you can paint, that's awesome. But imagine you're trying to learn how to paint. And think about what are the things that you should actually be doing with your time if you want to become a better painter, right? Which of these, which I'm about to lay out as possible things that you could be spending your time doing, is going to be most valuable to your growth? 1, sitting in front of your canvas and painting yourself. 2, going to a painting class and watching watching Bob Ross, reproduce it and trying to reproduce his work. Having one-on-one instruction where they're just trying to talk you, like they're whispering into your ear, okay, go a little bit to the right, now drag it down, and like telling you each stroke that you're trying to make. Trying to just watch a friend and copy without there even being instruction or a dialogue and just trying to mimic someone else. And lastly, watching Bob Ross while not painting yourself and laying in bed, which is most of my professional painting training has come from number 5, just watching Bob Ross, the famous YouTuber, stream his show and not painting alongside of him. And I can tell you right now, I'm a horrible painter. And so it turns out programming involves a very similar set of needing, or comes from a very similar place of needing to practice in order to become better at it. And showing up to class is great. Following along with the things that we do in class is expected. But one of the best things you can do, and you'll get a chance to do this on the exercises and our open-ended projects, is just sitting down in front of the computer and trying to bring something to life and paint and programming for yourself. All right, so I went through those questions and answers, and there will be another section where I'll open up for questions in just a moment. All right. So what I want you to think about right now is, how do you believe programming will be valuable towards achieving your personal goals? as we saw, most of you are not computer scientists, and that's okay. That's what this class is who this class is designed to serve, is the broad UNC audience that is enrolled. But what I want you to think about and really reflect on is, if we're going to spend an entire semester together learning how to program, how is that going to be valuable to you in the things that you want to achieve in the future with your career or with your own personal goals? So I want you to think about this question for a couple of minutes and write down your thoughts. And in about a minute, I'm going to open up a place to respond on Poll Everywhere, and we'll come back to what you responded with in just a moment. All right? So I want to give you a chance to think about this. I'm going to just pause here for a moment, and I'll open that poll on Poll Everywhere in just a sec. All right, I've been looking at some of the responses coming in, and I want to give everyone a chance for a few more minutes to respond. So while these responses are coming in, I'm going to talk through a little bit about how to think about computer science. And I want to frame this discussion that's about to happen in terms of a sort of a worldview brought on by the founding member of our computer science department, and that's Dr. Fred Brooks, pictured here in his youth, where he was inventing and helping manage the project, which was the IBM 360 computer. Fred founded our department over 50 years ago and is a legend among legends in computer science. And what Fred, one of my favorite quotes of Fred's, and then we'll come back to talking about the toolsmith idea in just a moment, is this one. And he writes this in his book, The Mythical Man Month, which is a seminal book in computer engineering and in software engineering. The programmer, like the poet, works only slightly removed from pure thought stuff. And what we're talking about here is this idea that when we're writing programs and code, we really are expressing ideas in a medium that has a language, has a grammar, and we're trying to find harmony and symmetry in many ways in the things that we are producing. And so if you enjoy writing poetry, I think that writing programs actually feels a lot like that at times, where you're trying to make things fit together in certain ways and looking for alternative solutions to a problem. But primarily we're working in a medium that is purely in our heads and then in the computers, but we often can't see what's actually directly in the computers. She builds castles in the air, from air, creating by exertion of the imagination. And so I think that what you're going to find when we're working on projects is that you're going to have these ideas, and your imagination is going to help drive you forward in terms of working towards these ideas that you have, that you want to see brought to life inside your computer. And this is what's really captivating about working in the programming medium and in computer science. Few media of creation are so flexible, so easy to polish and rework, so readily capable. Right? One of the things that's, I think, addicting about programming is that as soon as you finish whatever it is you were trying to write, you can immediately get some feedback as to whether or not the computer is able to run it and whether it was successful. And you can quickly iterate on that and try new things out. You're not waiting weeks or months or years for results like you are in many other fields where you're trying to invent something. And so you just have this flexibility that's a pretty wild power to have at our fingertips, in our pockets with mobile phones and on our laps with our laptops. And the power of computation is something that once you know how to wield it is very fun to explore with and leads to some fascinating results. So this is a favorite quote of mine from Fred Brooks, and he, as I mentioned, was the founding member of the UNC Computer Science Department. Another quote I like that brings us down even simpler is think, type, and magic happens. This is a professor of computer science at UNC, Professor Gary Bishop, who creates programs and software for people with disabilities. And he made a website called Tar Heel Reader that allows people with motion impairments to be able to navigate and read books and learn how to read by only needing to be able to press 2 buttons. And so Tar Heel Reader reads the books to the students and engages students who previously didn't have access to books because they didn't have the motor skills to be able to read through them. And so this is a fantastic application of computer science that has made a real impact on the world. And in COVID-19 days, the readership of his website has gone up tremendously. There's now over 14 million books have been read on Gary's website. There's one more set of quotes I want to talk through real quick. And these are from a really impressive member of computer science history. And I'll start with the quotes and then we'll get to who it was in just a moment. To me, programming is more than a practical art, an important practical art. It's also a gigantic undertaking in the foundations of knowledge. We're going to be studying data science as an application of computer science. And what Grace Hopper, who wrote this quote, is talking about is this idea that computation for computation's sake isn't that interesting. But when we apply computation to data that we want to analyze, learn from, or infer things from, we can do really powerful things. Humans are allergic to change. They love to say, we've always done it this way. I try to fight that. That's why I have a clock on my wall that runs counterclockwise. I love this quote. And this really gets to the spirit of what I think many computer scientists embrace, which is this idea that we shouldn't just do things for the sake of doing them for how they've always been done. We should try and reinvent things. And this semester, I'm excited to say we're reinventing the way that we're doing COMP110. So these are quotes from Dr. Grace Hopper, who invented the first programming language and was a seminal member of the computer science founding membership and really led the field in the early 50s and was a member of the Navy as well. The last thing that she said is, if you've got a good idea and it's a contribution, I want you to go ahead and do it. It's much easier to apologize than it is to get permission. And so one of the things that you're going to see us doing this semester, which is new, that no one really gave us permission for. So Kevin Guskowitz, if you're watching, hopefully this is fine with you. Chat, he's not watching the stream. But we're going to be opening up public access to our materials. Now, when members of the public are learning from our lectures or our recorded lessons, they're not going to have any access to the same help resources that you have in office hours and with our UTAs. So there's a big advantage to being a student. This isn't something that you could just take any other way out in the public. But I'm really excited to bring a high quality introduction to programming to the rest of the state and even beyond. This is something that I've hoped to do since I was in high school and didn't have access to a computer science class of my own. And so if you have friends or know of high school teachers who would maybe send this along to their students, that'd be great. You'll see this on our course website as we move into the semester. All right, so let me go through some of the chat responses to how do you believe programming will be valuable toward achieving your personal goals. It will help me teach others how to code and improve my competitiveness in jobs. I saw the word jobs in a career come up in many cases. I think there are fantastic careers, as you heard from two of the members of the computer science community who have recently graduated and what they're doing. And we'll have other members who are out at Google or Facebook or at smaller companies that are doing software engineering or at CS for social good type organizations that are really trying to improve the world with computer science. Allow me to adapt my methods of thinking and step out of my comfort zone, chat writes. Yes, I've got a slide on this in the very near future, but we will push you outside of your comfort zone if this is your first time programming or if you don't have a great deal of experience, which is most of you. It's a really weird thing to try and think in terms of a computer and to write in a language that has very much more specific rules than you're used to needing to follow. And often doesn't do what you think it's going to do. But with practice and repetition, you'll have a strong handle on it, and I'm sure you'll succeed. All right. One of my mentors told me that many doors would open for me if I knew how to program, and I'm studying in the biology field and looking into medical research. I had a slide that mentioned Fred Brooks put forth this idea that computer scientists are fundamentally toolsmiths. And if we think about medical applications of programming, this is absolutely the case. One of the research clusters in our department that is most active today is the Medical Imaging Analysis Group, and they have a long history at UNC. And so this group is focused on writing software and algorithms that process medical images like x-rays or CAT scans and tries to help doctors understand what they're working with, identify potential concerns, or potentially even help to diagnose certain problems and provide an extra set of eyes without needing an extra set of an expert. And this will be awesome for bringing medical resources to places that are underserved. All right, let me take one more. Scrolling through, these are great. Seeing a lot of commonality here. It will help me discover what I want to do. So I think one of the things that you'll be surprised by as you're learning how to program is that you'll start to see more opportunities for applying software or data science to solve a particular problem. And there's so many fields right now that are flush with data, that need analysis, that labs around campus that could really use people who know how to program to help them analyze the data that they're collecting. And the amount of data that we're collecting today is exponentially greater than it was even a few years ago. And so there's an immense need for applying computation to many different disciplines. And I think that by having this skill in your pocket, you'll be able to identify opportunities that you would have otherwise thought you weren't well suited for, and will help you hopefully navigate where it is that you want to go in the next few years. And whether that's in a computer science direction or not, I think that you'll find this a valuable course and get out of it what you put into it. All right, well, these were great. I'm gonna close down that question for now, and we'll keep reading through those after class ends. So now I wanna jump to the first and only real small lesson of the day, which is introducing to you a fundamental pattern in computer science, right? This is a pattern that applies in many different scenarios, whether you're programming or thinking about how to solve a problem. And what you'll find is this actually applies in many domains outside of computer science because it's a very abstract idea. But oftentimes you'll find that when we put our ideas or try to frame our ideas in terms of this pattern, more obvious solutions tend to fall out. So most problems in computer science start by specifying, well, what is it that we're actually working with? What are our input materials? What is the data that we have coming into our program, and how do we think about that? Your inputs are going to be fed to an algorithm, and the algorithm is the program that you're writing, right? So this is the code. When you're writing code, we're thinking about this as we're writing some algorithm to process some inputs. And when we have an algorithm, we tend to want to have something that is going to be a desirable result, right? So on the other side of our algorithm, if all goes well, we expect some result, right? An example of this would be, as I mentioned, in medical imaging analysis. You give inputs, which are the medical images, and the result is here are some problem areas that you should really be focused on based on our analysis in this algorithm. One other aspect of this fundamental pattern is being aware of the environment that you're in. And so this algorithm is operating in some environment, and we'll see that our algorithms often have either take some cues, some context from the environment at large, and often have some effects on the environment that aren't necessarily the primary result returned by a given algorithm, but this is part of any given process. And so being conscious that there are going to be potentially some interactions with our algorithm outside of this very clean box that has some inputs and a single output will help us think about this. This idea will come up in many different places where thinking of it in terms of this diagram will be very helpful. This pattern will exist from single lines of code all the way up to complete programs. It's pervasive in the problems that you're going to be solving in computer science. As I mentioned, and this slide is mostly for reference, when you're working with inputs, you think of that as your input data or something that the person using your program is given to the program. If you were writing a program like Illustrator or Photoshop, where the mouse is being clicked on the screen or where a finger is touching the screen and how it's dragging around. If you're flipping through your filters on Snapchat, these are all inputs that are being fed into some algorithm and producing a result. We'll see that an algorithm is a fixed size set of steps that we write as programmers in order to try and achieve some task, and the algorithm returns some result, right? As I mentioned, the algorithm may influence the environment and vice versa. All right. I'm actually going to skip past this slide because there's a little bit more content I want to get to. But we'll come back to this in a future lecture. And what I'd like you to start doing is just thinking about places where in your domain or in your real life, you can imagine this pattern applying and starting to identify where you've got some inputs and where an output might be. All right, so I'm going to enable questions one more time, and then I'll come back to these questions in just a moment. So I'll end with some Q&A as soon as I open this back up. There are just a few more slides that I want to talk through. All right, I'm going to go back to questions. All right. So one thing that if we try to think of a kind of silly but common first representation of this pattern, if you imagine some input like flour, buttermilk, butter, salt, and baking soda, you might be wondering, well, what is the algorithm? What are we trying to produce here? And if I tell you that this algorithm is being applied in the state of North Carolina, that might actually change the way the algorithm runs a little bit, right? Because what we're probably making here is Southern biscuits, which are delicious treats of glorious nature that you should try and find if you are an out-of-state student in North Carolina for the very first time. Make it a mission of yours to find a way to Bojangles or Sunrise Biscuit Kitchen here in Chapel Hill to enjoy incredible Southern biscuits. The same algorithm, which we think of an algorithm in many ways as very similar to a recipe where you've got some input ingredients and you're working towards some result, is common, and this is often thought of as an analogy for what an algorithm is. The effects on North Carolina are that just amazing things come from making biscuits. And there's nothing better than starting your day with a great bacon, egg, and cheese biscuit. So let's talk a little bit about some of the logistics as we get into the course and what you need to be thinking about doing for the next lecture. As I mentioned in the Sakai site, the course webpage is 20f.comp110.com. There's going to be an itinerary there after class. I'll post a link to this video as well as the slides that we talked through. And when we do exercises, they'll be posted there as well. There's a resources area of the page that I'll send you to for getting your computer updated to be sure we're on the latest operating system. That's your goal for tonight. And then we'll be using Sakai for email announcements as well as other private information when we need to share it exclusively with you. For tonight, if you haven't registered for Poll Everywhere, but I think just about everybody has based on the number of responses that came in, I would encourage you to register for Poll Everywhere based on the instructions on Sakai. Do update your computer's operating system. This is your only task for tonight, right? I didn't even want to get to the point of installing other software because in May, Microsoft released a great update to Windows 10, and there have been some updates to Mac OS. And for the purposes of this course, just having the latest release of your operating system will help us avoid a lot of complicated tech issues down the road. Your first exercise will be released tomorrow evening, if not a little bit sooner. And this will get you installing the software tools we're going to use, the code editor, the programming language, and it'll be on your freshly updated laptop. You're going to set up a workspace where all of the work that you do for the semester will be in that workspace, and we'll walk you through what that means. And then you'll actually write your very first program on your own and submit it for credit. That'll be due Friday, so don't stress on that. We've got plenty of time for that. On Sakai, if you need to reach out to some undergraduate TAs and get help updating your operating system or installing your software when we get there, Sakai's resources page is going to have the instructions for how you access CourseCare. And CourseCare is what you do, is the app we use to request help in office hours and to connect with UTAs, and those instructions are on Sakai. We're actually going to have some hours tonight from 7 to 9. This is our first set of office hours of the semester. And then on Wednesday from 10 to 12 and 2 to 8, and Thursday from before class and after. So plenty of opportunities to come meet your undergraduate TAs and get help if you get stuck on something. So if you want to join us tonight and just meet somebody on the team and talk a little bit about computer science, that's great. But I would encourage you to get started on updating your operating system. And that's your primary focus for tonight. We do love feedback through the semester. At the bottom of the course site, there's a form for you to fill out if you want to leave feedback that'll come directly to me. This could be things like your mic was too quiet or ideas on how to improve the stream. The feedback form is found on the bottom of the site in the very footer of it. Please, please, please give us feedback while we have time to act on it. So as soon as there's something that you think we should do differently, let us know. We're working within some constraints because we need to make progress in the semester, and we've got a path that we generally want to chart. But for many things, we try and take every piece of feedback as best we can and incorporate it where possible. I will take some class-wide feedback through the semester. So be on the lookout. There will be an early survey coming out this week, and then we'll take other surveys as we move through it. Just trying to be sure that everyone is feeling good about where we're at and is in a good place. All right, so let me look at Poll Everywhere. So the first question that's got 110 magically votes is, do we have to download any software? Yes, there will be software that gets posted tomorrow. Don't worry about that tonight. Tonight, just focus on updating your operating system. All right, let me see what else. There's some that we've already talked through. All right. Specific questions about the exams we'll get to as we get into the course. And once you've had some practice with things like diagrams and exercises, you'll know a little bit more about what I mean when I say those types of things will be on a test. All right. What programming language will be used? Great question. I actually don't mention the programming language at all, specifically in the slide deck or on the website, because as an introductory programming language as an introductory programming class, it really doesn't matter. The concepts we're teaching are going to be applied to any programming language you want to use. So we're not going to be focused on learning a specific language that is that what you learn in that language won't really translate in other ways. But we will be using the Python programming language this semester and a very modern dialect of it that does have certain things that if you have any experience programming Python before, this will look a little bit different to you because we're using the best practices in 2020, and most instructional resources on Python are still a few years out of date. To connect on social media, YouTube, subscribe if you'd like. I will be posting videos here, as I mentioned, that will be asynchronous in addition to the synchronous lectures that we do together like this. On Twitter, you can, I love following along with students, especially if you have a public account. I won't follow your account if your account is private, but do follow me on Twitter if you want computer science updates. I think for people who are considering the major, I try and make useful retweets based on things that are I think relevant to students in computer science. And then if you want to follow me on really the only Instagram account you should follow is my Finstagram account or my Finsta. And I've got a new puppy who is now much bigger than this named Ada. And I like to make posts from Ada, all right? We're going to have an incredible semester despite the complications that we're operating under with COVID-19. I know this is probably the end of 2 really long days for you, having had your first day of classes yesterday and then another long day today, and we come late in the day. But I really appreciate the energy you brought to responses on Poll Everywhere. And it looks like we've still got time for a few more questions. So let me take a few more if there are any, and then we will close out the stream. Assignments and everything you need for the course will be on 20f.comp110.com. And so the only assignment right now is making sure your computer is up to date. Like, that's actually so fundamentally important for making sure everyone's on the same page in the course that we didn't want to assign a first programming project ahead of that, because we expect that most of you will need to install some updates tonight, and that can take between 20 minutes if you're reasonably up to date to a couple of hours. All right. We will be using the VS Code toolset for writing our programs. Don't worry about that. We'll have instructions on how to get that going here in just a moment. In terms of preparing for Thursday, all you really need to do is get your operating system installed, and then there will be some extra instructions to start moving through, but we won't expect that you have completed them by Thursday's lecture. On Thursday, we'll start introducing some of the fundamental programming concepts, like what are programming languages, what is an operating system, how do we think about the machine level code, and then start to introduce some very fundamental programming concepts. But we'll get there in due time. And I just want to end the stream here and say thank you so much for joining. I hope to get to see you on campus soon in a safely distant way. This is, as I mentioned, a really, really strange semester, but I think that we're going to make the most of it. And so I'm actually optimistic that this is going to be the best offering of COMP110 we've ever had. And we're trying to utilize these various mediums that we now have available to us to bring you the easiest access to undergraduate teaching assistants as we can. Previously, you would have to go to a building and actually walk across campus up to North Campus in order to work with undergraduate TAs, and you couldn't access them from anywhere else. But being able to reach out to your UTAs virtually and meet over Zoom this summer proved to be an incredibly valuable way of connecting, and actually lowered the barrier to getting help in a way that we would be doing even if we weren't fully remote. We've got some crazy times ahead of us, but I'm excited to focus on learning how to program with you. And I think this can be a great escape from anything else that's going on in the world. So with that, I'll see you all on Thursday, and have a good rest of your initial classes. See you soon.